Hello again, this is Dr. Mahmoud. We're going to continue on sequencing rules. We did talk about their different rules that we can use. These rules, just as a reminder, the first come, first serve, earliest job due date, and then shortest processing time and critical ratio. And we did talk about the some of the benefits, advantages, the disadvantages for each of one of them. And now we also did cover the an example on the sequencing rule. So for example, if we're going to the first come, first serve, the first one arrived in this example would be, which is D right here, which is came in day 219, and then would be A, which is came in 223, and then B, and then C. Earliest due date, that would be based on the due date. We're going to use this column right here. And for the operations due date, this is one of the things that I did not cover earlier, but there's one of the sequencing rule called the operational due date based on the operations time. And the sequence would be based on the from the shortest to the longest operations. So that would be 233 first, 239, that's B, and then C and D. And for the shortest processing time, we go to the process time here in this column, and we sort these jobs based on the processing time. Now, what we need to do, we need to take even more details and more a more advanced example, and we will apply these parameters. We're going to use the average flow time, average of tardiness, and average number of jobs at workstation. We're going to use these three measures to select what would be the best sequencing or scheduling order for these jobs. First of all, let's talk about the one of the concepts that mentioned in the textbook called the make span, which is the total time needed to complete a group of jobs. Think about it as a lead time. How long will it take you to finish the job if has more than one group? So it's just different jobs, and you need to complete them with each other to complete these jobs based on the lead time. So basically, you add the lead time for job one plus job two, etc. That's what we call the make span. And we need to talk about the average flow time, which is total flow time divided by the number of jobs. Average tardiness, which is the total hours of tardy divided by the number of jobs. Average number of jobs at a workstation would be equal to the total flow time divided by the lead time, which is the make span. All right, let's take a look into this example. This is a first example that we need to talk about. We're going to spend much time here on this example. Processing time, including the setup time and due dates for 6 jobs waiting to be processed at a work center, are given in the following table. Determine the sequence of jobs, averages, the average time, average tardiness, and average number of jobs at the work center for each of these rules. First come, first serve, shortest process time, or the short process time, early due date, and a critical ratio. And we have these jobs from A to F. Processing time is given, and the due date also is given for each one of these jobs. All right, now let's go ahead and try to apply this. The first one, A, first come, first serve. So what I want to do, I want to share my Excel screen here. Excel sheet, here is the Excel sheet. This is the example, and we'll walk you through the example. So the first come, first serve, this is what they told us. It came as A, B, C, D, E, and F. So that's what would be. So the process time is 2. The flow time for A would be 2. The due date is 7. That is given to us. As you see, I want you to keep an eye on this table as well, because the table will change. Now, do we have any tardiness or late? No, we're going to finish it in 2 days, for example, on day 2. And the due date is 7, so there's no late here. B, we will know that job A will finish, and then we'll be moving to job B, which is will take 8 days. So if we're going to start with B after A, that would be 10. So that's 8 plus 2, that would be 10. The due date is 16, that's given to you here from this table, from the question. And now moving into the C, C processing time is 4, this is given to you. So the flow time, we're going to add 4 more days on the top of the 10, that would be 14. And then move on to the D, add another 10 to the 14, that would be 24. And then add 5, that would give you 29, the processing flow for E. And then F would be 41, which is 29 plus the 12, that will give you 41. Now we add these together, the processing time, we need 41 days. And flow time would be adding these together as well. Now the due date is given to you by the question. And now your job is to find out if there's any late in these orders by comparing the due date and the flow time. So the flow time is less than the due date, so we don't have any delay. Same thing for B. For C, we have a delay because the due date is for day 4, and we're going to finish it on day 14. So we have 10 days of delay. Now moving into D, the due date is 17, and we're going to finish it by 24. So there are 7 days delay and 14 days of delay here. The difference between 29 and 15. And now adding these together, that will give you a total of 54 days of delay. Now, if we need to calculate all of these parameters that I give it to you here, I am going to put it here as well so you could understand what equations that I'm using. So the average flow time would be the total time divided by the number of jobs. So the total time would be the 120, that's the total flow time, divided by 6 jobs. And now for the tardiness would be the total delay time, which is G12 here in my cell, which is 54 divided by 6. And then the average number of jobs would be 2.93, which is coming from dividing the flow time by the 41, the processing time, that will give you 2.93. Now leave these there. Now we're going to move on to the next part, which is part B, the shortest processing time. And let's see, and then we will come back and compare all these variables to each other and then pick the best scheduling technique. All right, for the shortest short process time, we're going to start with a look at the process time. Again, this is given to you here, the process time, as you see in this table. 2, 8, 4, 10, 5, and 12. So you will see that A is the shortest processing time of 2 days, and then followed by C. So now the rank would be A, C, and then E, and then would be B, and then D, and then F. So A, C, E, B, D, and F. This is the rank. And now we're going to do the same thing for the flow time based on the processing time. And then we will also calculate the delay if there's any delay or late process based on the due date comparing to the flow time. So, okay, so we did agree that based on the short processing time, the sequence would be A, C, E, B, D, and F. And then we take these information from the table in the flow time, starting with a 2 here. And now moving, once we're done with A, we're going to move to C. 2 plus 4, that would be 6. So that job will be finished on day 6. And then 6 plus 5, that would be 11. And then 19, which is the 11 plus 8 days to finish B, so that you will be able to finish B on day 19. And 19 plus 10, that would be 29. 29 plus 12, that would be 41. Adding these together, that will give you a flow time of 108. This is what would be the flow time. And now let's compare this with the due date. Due date is given to us here in the question. So let's say the due date for A is 7 and we are on day 2, so there's no delay. For C, we have a due date 4 and we are on 6, so there's 2 days of delays. Now for E, the due date is 15 and we are on 11, so there's no delay, 0. Now here for B, the due date is 16, we are on day 19, so there are 3 days of delay. And now here we have 17, that's the due date, and we are in 29, so there are 12 days delay, and 23 for F, adding these together. And now let's calculate these parameters. We found the average flow time would be 108 divided by 6, which is 18. Again, look at this. This is shorter than the first come, first serve. Average tardiness would be 2.83. So still also way less than the first come, first serve. And the average number of jobs, that would be 2.63. And this is calculated by dividing the flow time by the process time, which will give you this factor of an average number of jobs, 2.63. And therefore, the short process time is so far better than the first come, first serve. Now we're moving into part C, which is the early due date. So now we're going to rank these tasks based on the due date. So looking into the information that is given to us, you will find out the due date for the shortest due date would be, or the earliest due date would be, which one? Would be due date of 4, that would be C, as you see here in this right here. This is what we're looking for in this table. So C would be the first, and then moving into the next due date, which would be A of 7. Then after 7 would be E, so C, A, E, and then B, and then D, that would be the 17, and F would be the 18. So the rank would be C, A, E, F, D, C, A, E, B, D, F. And now we're going to do the same thing using the process time for each one. We're going to calculate the new flow time for this sequence. So will be 4. And then after the 4 would be 6, which is 4 plus 2. And then 11, 6 plus 5, then 19 plus 10, that would be 29. And then 29 plus 2, that would be 41. Adding these together, that will give you 110. And let's now find if there's any delay. As you see, comparing the due date with the flow time, we are on day 4. The due date is 4, so we're not late. The due date is 7. We are on day 6. There's no delay. 15 versus 11, no delay. Now 16 is the due date for B. However, we are on day 19, so there are 3 days. We're 3 days late, and 12 days for D, and 23 for F. Again, just to compare the due date with the current flow time, and that will give you 38 days of delay. Now let's take a look into these 3 parameters: the average flow time, tardiness, and average number of jobs. And that will give you 18 for the first parameter, which is you divide the flow by 6, the flow time by 6, 110 by 6, and then moving to the next one, 18.33. So that's better than first come, first serve, but it's not short process time is the best so far. Moving into the tardiness, we have 6.33. This is calculated by divided the 38 by 6, and then average number of jobs also divided by 110 divided by 41. That will give you 2.68. So far, the short process time is the best between the 3. Now we're going to move to the critical ratio sequence, and that's going to take us a while to figure it out because we have to walk by each process and start eliminating that. So let's go ahead and work on this. So the critical ratio, what is the critical ratio? The critical ratio can be calculated based on the due date minus present date divided by the lead time remaining. So in here, what we could do, first thing we need to do, so we took the information from the table, the original table, A, B, C, D, E, F, and now what we're going to do, we're going to calculate the CR ratio. So as you see, the CR ratio can be calculated by the due date minus the present date. So for example, we are on due date 7 for A. We are on day 2, so 7 minus 2 minus Okay, we are on day 0 right now. So 2 minus 0 divided by the due date of 7. So that would give you the 3.5. One more time, just I think want to make it clear. So the due date, we are on day 7. That's the due date. The due date is 7. We are on day 0. So 7 minus 0 divided by the processing time, which is the lead time, that would be 3.5. Do the same thing for B, which is the due date. The due date for B is 16. We are on, after processing 1, we are on, we haven't processed anything yet. We are on present date. So I want to add this actually just to avoid any confusion. The present date is equal to 0 right now. We are on day 0. Okay, so due date is 16. The current date is 0. So 16 minus 0 divided by the process time, that would be 2. And for C, that would be 4 minus 0 divided by 4, that will give you 1, and so on. Now, as you see, the critical ratio 1 is the first one that we should be eliminating. So now the first and the sequence should be C. Now what we're going to do, we're going to move on to the next task, and we'll have to do the same thing. However, we did agree that C should be done first. So we are in day 4 right now. All right, let's go ahead and find out what would be the next process based on the CR calculation. So again, the CR would be the due date minus the present date. The due date here is 2 minus the present date is 4. So we have due date is 7 minus 4. That would be 3 divided by 2. That would be 1.5. For B, that would be the due date 16 minus 4 divided by 8. That would be 1.5. And we do the same thing. C, we don't talk about C at all because it is eliminated already. We picked it. So we'll ignore C here from this table. Let's see if we could hide that. All right. Ooh. Yeah, we could hide it if needed, but ignore it. Just I did strike it here. Just to make sure that it is ignored. We're done with it. It's scheduled as the first one. And now we do the same thing for D, E, and F by calculating the CR due date. Due date, for example, for F is 18 minus the current date. The present date is 4 divided by 12. That will give you 1.16. Based on the CR, the second operation, the second job should be F. So now the sequence would be C, F, and now let's ignore both C and F and move on with the rest of the jobs by calculating the CR. And once we look into here, we found out that A is the shortest here. So A should be eliminated as well based on again, the due date minus the present date. Again, the present date right now is 16. Why is this 16 coming from? Because we're already on day 4 and we agree that F should be going next. F will take us 12. So 4 plus 12, that would be 16. This is where we are bringing the 16 from. And once we calculate the CR, the critical ratio for all of these, we found A should be next. So the sequence should be C, F, and A. And then moving into the next task, the present date would be 16 plus how long will take us to process A? 2. So 16 plus 18, 16 plus 2, that would be equal to 18. Now let's calculate the CR to considering the present day of 18. The due date for B is 16 minus 18 divided by 8. That will give you a negative 0.25. And for D would be the due date for D, which is 17 minus 18 divided by the processing time 10, which is negative 0.1 and negative 0.6. As you see, the lowest one would be the CR, and that would be the next step that we should consider. That's the next step that should consider, or the next job that we should consider. So far we have C, F, A, and now E joined the team. Now that would leave us with 2 operations, B and D. Do the same thing. The present date for today for this process would be 18 plus E will take us 5, so 18 plus 5, so that would be 23. Now let's calculate the CR based on the present day of 23 for B and C. We found out that B has the lowest CR, so we have to go with B for that. So the sequence would be A, B, C, D, E, and F. That's the rank. Again, C, F, A, C, F, A, C, F, A, E, B, and D. That's a rank. And now we build the table based on this order. So we have C, F, A, E, B, and D. Now add the processing time. Let's find what would be the flow time based on this, the new flow time. All right, so starting with the C, process time is 4, due date is given to you 4, so the flow time is 4. Now moving into the next job, which is F, the flow time would be 4 plus 12, and then 16 plus 2, that would be 18, and then 18 plus 5, that would be 23, 23 plus 8, that would be 31, 31 plus 10, that would be 41. Now adding all these flow time together, that would give you 133. Process time is 41. Now the next step is to find the day and the delay, how many days are late. So that would be comparing the due date with the flow time. So 4 and 4, that's 0. The due date is 18. The flow time is 16. So there's also no delay. Here there's a delay for A. The due date is 7. And the flow time is 18, so there are 11 days delay, and so on, and then you can add them together to find out there are 58 of delays, and therefore, and if you look into the 3 parameters, the average flow time to 22.17, that would be 133 divided by 6. Tardiness is 58 divided by 6. And then the average number of jobs, 3.29. Now, what I want from you is to go back to all of these previous results and select the best job. And it looks like the best job for this would be the shortest process time. And let's go now back to the slides to conclude this here. So based on the slides, here's the conclusion. The conclusion is these are the 3 parameters: the average flow time, the average tardiness, and the average number of jobs. And then it looks like the shortest process time rule would be the best according to 2 of the measures of effectiveness, and little worse than the early due date rule on average of tardiness. So therefore, I think we should select the the shortest process time. The CR rule was the worst in every case, so we should not pick the CR rule. All right, well, I'm going to stop the video right here, and I will be recording another video on another technique, which is the slack time, the slack per operation rule, and we'll see you in another video.